Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 15th, 2025, about 3 days ago. The striking result is that continual pre-training on junk social media text causes measurable cognitive decline, with ARC challenge using chain of thought dropping from 74.9 to 57.2, and ruler CWE falling from 84.4 to 52.3 as junk rises from 0 to 100%. The paper is titled, LLMs Can Get Brain Rot, and the implications from model training are quite significant. The authors trace the damage to thought skipping, show that popularity signals are especially harmful, and find that scaled instruction tuning only partially heals the decline. Alright, the previous segment highlighted the main declines and their partial recoveries. Figure 1 presents the study blueprint, which links junk social media exposure to cognitive decay through a controlled pipeline. The top hypothesis panel defines junk via short and popular or sensational content, contrasted with longer or cognitively demanding posts. The left pipeline constructs junk and control mixes, then applies continual pre-training, followed by instruction tuning. The right panels summarize outcomes and analysis. Reasoning, long context, safety and personality drop, thought skipping dominates errors, and fine-tuning plus reflective reasoning serve as mitigations. Well, Figure 2 tests whether popularity and length track semantic quality. The left panels indicate that popularity barely relates to length or to semantic quality, so popularity behaves as a non-semantic signal. The middle violin plot shows longer tweets concentrate in the high-quality group, which aligns with the intuition that length correlates with richer content. The right matrix confirms strong agreement between human and model labels, with most samples on the diagonal. So Figure 2 showed that popularity is a non-semantic signal. Table 1 lists the evaluation suite, which spans 4 cognitive functions, so the intervention's effects are measured broadly. Reasoning uses ARC, framed as visual program induction puzzles on grids. Memory and multitasking rely on ruler for long context retrieval and aggregation. Ethical norms combine HHR-LHF and ADV bench to test refusal of harmful prompts, and personality uses trait questionnaires to assess tendencies. So Table 1 set the evaluation scope, and Table 2 shows the dose response across junk ratios for Llama 3 8 billion instruct. The reasoning block reports steep declines, with ARC challenge using chain of thought near 57 at 100% junk under M1, which tracks a stronger harm than M2. Long context tasks drop as well, with ruler CWE around 52 at full junk. Safety risk scores rise substantially, so lower values are better but they increase with junk. Personality measures shift toward darker traits, with narcissism and psychopathy climbing while agreeableness falls. Okay, Table 2 showed a clear dose response. Figure 3 presents effective sizes across tasks, which quantify how much the junk intervention shifts behavior relative to the control. The left panel shows negative shifts for reasoning and long context, with engagement-based junk producing larger declines than the semantic quality version. The right panel plots safety and personality, where lower is better, and it shows bigger increases in risk and dark traits under engagement-based junk. Error bars give 90% confidence intervals. Well, the previous figure quantified overall harm. Figure 5 breaks it down by failure type in chain of thought reasoning. The full chart shows failure counts by dataset condition, and the tallest stack occurs for junk M1. The leftmost bar is dominated by the no-thinking segment, with added increases in no plan and skipping steps, which signals thought skipping. Control and baseline bars are shorter, so fewer answers fail for these modes. So the previous figure unpacked failure types. Table 3 isolates which junk metric matters. The AR challenge using chain of thought block shows popularity hurts reasoning more than length, with drops of about 17 versus 10 points, and the full M1 mix falls the most. The ruler block flips emphasis, where short length damages long context more than popularity, roughly 17 versus 14 points. The adventure risk block worsens most under short length, rising by about 29 points, while M1 adds around 11. Alright, 2 takeaways stand out. Junk social media exposure measurably degrades reasoning and long context skills with a clear dose response, and thought skipping is the dominant lesion, while popularity signals are especially harmful. The broader implication is that data curation is a training time safety issue, demanding routine cognitive health checks. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.